Good morning to everyone. In previous video, we have discussed about the kinematic chain and mobility of mechanisms. Now, types of kinematic chains we'll discuss in this video. Okay, mobility of mechanism or number of degrees of freedom calculation we have discussed in the last video. Now, we are going to discuss about inversion of mechanism first. What is inversion and then what are the different mechanisms, kinematic chains or different kinematic chains we are going to discuss. Then inversion of 4-bar chain and slider crank mechanism will be discussed in this video. 4-bar chain, inversion of 4-bar chain and single slider crank chain will be discussed in this video. Now what is inversion of mechanism? One of link is fixed in a kinematic chain, it is called a mechanism. So any one link is fixed, then it is called as a mechanism. If it is by changing the number of links, okay, by fixing of different links at different times, then it will be getting different mechanisms. Okay, that process is called as inversion of mechanism. You can obtain as many mechanisms as the number of links in a kinematic chain by fixing in turn different links in a kinematics. So right, in a kinematic chain, we are fixing in different links, different mechanisms you are going to get. This method of getting different mechanisms is known as inversion of mechanism. Method of obtaining different mechanisms by fixing different links in a kinematic chain is known as inversion of the mechanism. Now, the relative motion between the various links is not changed in any manner through the process of inversion. By making the inversion, the relative motion is not changing, but the absolute motion may change drastically. Each link absolute motion may be different in inversion of mechanism, but relative motion will not be changed. The part of a mechanism which initially moves with respect to the frame or fixed link is called driver. So initially moving with respect to fixed link is known as driver or crank. Okay, fixed link is called driver, and that part of the mechanism with which motion is transmitted is called follower. Okay, whichever motion is transmitted, then it is called as a follower. Most of the mechanisms are reversible. That is, some link maybe sometimes maybe plays a driver role, sometimes it plays a role of follower. Okay, different times, different way it will be acting. So that example, reciprocating steam engine you are taking, that piston end is the driver and flywheel is a follower, while reciprocating air compressor, same mechanism but it is acting as in a compressor, then the flywheel is a driver. Okay, that is the difference. Now, so different times different elements will be acting as a different way. That is, one time it may be driver, one time it may be follower, like that. One more time it may be a coupler, like this it will be acting. Now this is about the inversion of mechanism. Next one is types of kinematic chains. Different chains, okay, are those which consist of 4 lower pairs, each pair being sliding pair or turning pair. So most important kinematic chains are 4 kinematic pairs, 4 lower pairs. So each pair being a sliding pair or turning pair. 4 lower pairs are having, then the four links are there, then it is called a simple mechanism. That simple mechanism or simple kinematic chains or sliding pair and turning pairs may be present. Now 3 types of kinematic chains are very important now for our syllabus point of view. 4-bar chain or quadric cycle chain is the first one. First one is 4-bar chain or quadric cycle chain. Second one is the single slider crank chain. Third one is the double slider crank chain. So these are the different kinematic chains: 4-bar chain, single slider crank chain and double slider crank chain. Now one by one we'll discuss. So first one is 4-bar chain or quadric cycle chain. So this 4-bar chain you are observing is a combination of 4 or more kinematic pairs. It is a combination of 4 or more kinematic pairs such that the relative motion between the links or elements is completely constrained. Kinematic chain is a combination of 4 or more kinematic pairs such that the relative motion between the links or elements is completely constrained. The simplest and basic kinematic chain is a 4-bar chain or quadratic cycle chain. Simplest chain is 4-bar chain or quadratic cycle chain. It consists of 4 links. Each of them forms a turning pair at A, B, C and D points. 4 turning pairs, okay, at A, B, C and D, 4 links. The 4 links may be of different lengths, okay, 4 links are maybe different length, but according to Grasshoff's law for a 4-bar mechanism, the sum of the shortest and longest link lengths should not be greater than the sum of the remaining 2 link lengths if there is to be a continuous relative motion between the 2 links. If there is continuous relative motion is present, then there is a condition should be satisfied, that is sum of the longest and shortest distance or longest and shortest link lengths should not be greater than the remaining 2 link lengths. So this is the Grasshoff's law for the 4-bar mechanism. So this is one of the important bit maybe in public sector point of view. So for Grasshoff's law of a 4-bar mechanism, the sum of the longest and shortest link length should not be greater than the remaining 2 link lengths. So now this is the 4-bar chain you are observing in this figure. AD is the shortest link, BC is the longest link. AD is the shortest link, CD is the shortest and longest link lengths. The sum of AD and DC should not be greater than the sum of the AB and BC. Okay, so this is the way we can say that, okay, 4-bar mechanism, Grasshoff's law satisfaction. Now, a very important consideration in designing a mechanism is to ensure that the input crank makes a complete revolution relative to the other link. The mechanism in which no link makes a complete revolution will not be useful. So generally, in designing a mechanism, to ensure that input crank makes a complete revolution relative to the other link. The mechanism in which no links makes a complete revolution will not be useful. Okay, in a 4-bar chain, one of the link in particular, the shortest link will make a complete revolution. 4-bar chain, complete revolution will be taking place by shortest link. Okay, other 3 links will be followed. Okay, if it satisfies the Grasshoff's law, such a link is known as crank or driver. When the shortest link is making complete revolution, that link is called as driver or crank. Okay, now link in the figure, AD is the crank. The link BC, which makes a partial rotation or oscillates, is known as lever or rocker or follower, and the link CD, which connects the crank and lever, is called connecting rod. CD is the connecting rod which connects the crank and lever, is called connecting rod or coupler. The fixed link AB is known as frame of the mechanism. Okay, fixed link is called as frame, and coupler is the one, another one is rocker, another one is crank. These are the 4 links. So when the crank is the driver, the mechanism is transforming rotary motion into oscillatory motion. Transforming rotary motion into oscillatory motion. Now we'll discuss about inversions of 4-bar chain. Now inversions of 4-bar chain, many inversions of the 4-bar chain. Now main important one we are discussing now. First one is beam engine or crank and lever mechanism. Beam engine or crank and lever mechanism. That figure I will show you later in the next slide. So now beam engine, nothing but it consists of 4 elements or links. Okay, it is a part of the mechanism of a beam engine, also known as crank and lever mechanism, which consists of 4 links. Okay, this beam engine consists of 4 links. Okay, our crank and lever mechanism has 4 links. In this when the crank rotates about the fixed center A, the lever oscillates about a fixed center D. Okay, crank rotates about A and lever oscillates about a fixed center D. ND of the lever CD is connected to a piston rod which reciprocates due to rotation of the crank. Okay, in this case, the purpose of this mechanism is to convert rotary motion into reciprocating motion. So this beam engine mainly converts rotary motion into reciprocating motion, or reciprocating motion into rotary motion. So now as the crank rotates in this figure, you are observing, okay, crank is connected to the AB and BC is the another link 3, okay, connecting rod, lever is the CE and remaining is fixed element. So that means, so lever is connected at the end of the lever E. Point piston is attached to the by means of piston rod. As the piston reciprocates inside the cylinder, so this lever will be oscillating. That causes to the coupler will be moves. Okay, that causes to the crank. As the crank rotates, coupler is oscillates. Okay, lever is oscillating. Okay, this BC is the coupling rod. Okay, connecting rod, connector between the lever and this crank. So this is about the beam engine. Now coming to the coupling rod of a locomotive or double crank mechanism. This is another inversion of the 4-bar chain. Another inversion of 4-bar chain. So in this case, AB is the link fixed and BC and AD are the two cranks, because these two are making complete revolution, and this CD is the coupler or connector between the two cranks. Okay, link 2 and 4 are connected by means of link 3. Link 1 is the fixed one. So in this case, as the crank AD rotates, crank BC also rotating. So that's why this converts rotary motion of one wheel into transforms into another wheel. So the mechanism of a coupling rod of a locomotive, also known as double crank mechanism, which consists of 4 links. Okay, in this mechanism, the link AD and BC are the axis cranks and are connected to the respective wheels. The link CD acts as a coupling rod and the link AB is fixed in order to maintain constant center to center distance between them. The mechanism is meant for transmitting rotary motion from one wheel to other wheel. So this is the transformation of one wheel to other wheel. Next one is Watt's indicator mechanism or double lever mechanism. This is the last inversion of 4-bar chain. Okay, Watt's indicator mechanism, also known as Watt's straight line mechanism. This is one of the important questions for even in the second unit. Also, this topic is there. Watt's mechanism or straight line mechanism. Okay, one of the Watt's straight line mechanism or double lever mechanism, which consists of 4 links. Okay, the 4 links are fixed link at A and link AC, link CE and link BFD. So BF and FD forms one link because these two parts have no relative motion between them. BFD is the one link. The link CE and BFD act as lever. Okay, link CE and BFD are the acts as levers. Okay, double lever. Okay, that's why double lever mechanism. Now the displacement of the link BFD is directly proportional to the pressure of gas or steam which acts on the indicator plunger. So therefore, now one many small displacement of the mechanism, the tracing point E at the end of this link CE traces out approximately a straight line. So now this is Watt's indicator mechanism is a approximate straight line mechanism, because as E is approximately moving in a straight line. Okay, now in the initial position of the mechanism is shown in figure by full lines, whereas the dotted lines shows the position of the mechanism when the gas or steam pressure acts on the indicator or plunger. Now we are observing this is the figure. BFD is the one link. BFD is the one link. BFD actually combined as one link because there is no relative motion. This is connected at the point F is the piston rod is connected to the piston. Now as the piston or indicator plunger is reciprocates inside, okay, E is moving along a straight line. That's why it is it is approximate straight line mechanism. So as the link or AC is rotating, okay, then AC is rotating, so then reciprocates the BFD. Now then E will move along a straight line. Okay, this is the 4-bar mechanism. One of the inversion of 4-bar mechanism is Watt's indicator mechanism, or it is approximate straight line mechanism. Next one is last topic in this video, single slider crank chain. So in previous case 4 turning pairs only are observed in 4-bar mechanism. Now we are taking slider mechanism, or one of the slider crank mechanisms. This modification of the basic 4-bar chain. It consists of 1 sliding pair and 3 turning pairs. 1 sliding pair and 3 turning pairs. It is usually found in reciprocating steam engine mechanism. Reciprocating steam engine mechanism. It converts rotary motion into reciprocating motion and vice versa. That is, rotary motion into reciprocating motion, reciprocating motion into rotary motion is converted by using single slider crank chain mechanism. In a single slider crank chain, as shown in figure, the link 1 and 2, links 2 and 3, links 3 and 4 form 3 turning pairs, while the link 4 and 1 form sliding pair. Okay. Now the link 1 corresponds to the frame of the engine, which is fixed. The link 2 corresponds to the crank, link 3 corresponds to the connecting rod, and link 4 corresponds to the crosshead. So as the crank rotates, the crosshead reciprocates in the guides, and thus the piston reciprocates inside the cylinder. So this is the mechanism we are observing, single slider crank mechanism. As the crank rotates, crosshead will be reciprocates inside. As the crosshead reciprocating, piston will be reciprocates. Okay, now this is the frame. For link 1 is the frame, link 2 is the crank, link 3 is the connecting rod, link 4 is the crosshead along with the piston and piston rod. As the crosshead reciprocates, piston also reciprocates, or reciprocating motion is converted into rotary motion, or rotary motion into reciprocating motion. So this is the way we are using single slider crank mechanism. So now this complete the 4-bar chain and inversions of 4-bar chain and single slider crank chain we are discussed. So in the next video we are going to discuss about inversions of single slider crank chain. Thank you.